So unfortunately, just after we got all the panels sorted and on the bus, this happened. Storm Eunice. Destroyed, and put the other panels into the bus, and that one looks okay. That one looks okay. That one's destroyed. Where these have been attached, they've just been literally ripped off from the top of the bus. I was surprised the cabling. I must have ripped that one straight out. I'm not any kind of authority about telling anyone how to do anything, especially not how to convert a bus. I'm learning as I'm doing it. But if I can recommend anything, do it indoors if you can. It'll be so much easier. Now we've got snow. Okay, now I've got the scaffolding up. We're gonna have a look at it. It's gonna be the first time to look at the top of it now then. Yeah, there's definitely panels missing there. And these have been bent up, but they should be flat like this one. This whole thing has lifted off the bus and bent the strut back. Brutal. This one had the panels zip tied to it because I ran out of these things. These are, yeah, they're not going anywhere. So I guess the same thing has happened on this side. The wind's caught it from underneath and just blown the panels clean off it. Whereas this one, because they were hard connected to the brackets, have swung up and pulled the whole system back. At least these panels survived the wind. All the bolts and the clamps that I needed are on order, so they'll be here soon, but I needed to get up and check what state this was in. It's not been catastrophic. I always knew that I'd have to reinforce these. These are only here for future proofing if I make it tilt, but I think the safest thing to do now will be to replace these and reinforce them somehow. That one over there looks like it needs some attention now. Just really glad it didn't come down on top of somebody. If I'd have known, I would have done something more about it, but before I left, I made sure it was strong enough to deal with what would have been normal British weather, but didn't anticipate. I'll try and shore it up for the time being. So this is a couple of weeks later, because the replacement solar panels were delayed a little bit by the courier. So thankfully I'm able to do it in the sun for a change. So this is replacing that panel there, which has got a broken frame. No camera on the roof, so I couldn't tell exactly what was happening with these, but we've changed the brackets now, so we've got just flat 5-hole 6mm thick steel bar, which is just bent at a 5-degree angle, which matches the curve of the roof, and then they're clamped down. Now what happened last time was I ran out of the nuts that I need to attach these spring washers into, which meant that in the high wind the side of the panels flipped up, blew the panels off, broke all the zip ties. Luckily it didn't cause too much damage to anything else. So it's just a case of replacing the damaged panels making sure everything's bolted up now that I've got the right nuts and a replacement beam for this, and they should never come down again is the theory. So yeah, I'm just going to finish putting this bit of uni strut on here, and then we can put the other panels on. Cool. Now we just got to replace those 3. We'll add the 2 and replace that 1. Okay, time to disconnect and remove this panel. So these are wired in all in series at the moment, because I've only got the one charge controller, which is built into the inverter. So I had been running this in parallel, with both coming in and then both going in parallel from here, so that would be the right and that would be the left. But because I lost a couple of panels, I've seriesed these up, and these are live with 280 volts, so don't touch that. So all of this is now isolated from the charge controller, but not isolated from each other. So this has still got quite a lot of voltage going through it, but no load. I don't like these new style solar connectors. It just makes it more tricky to undo. Okay, so that was my jumper cable, which was just bridging the gap between the 2 lost panels. That is 3.4 kilowatts of solar panels. They better stay in the place that I put them now. Let's go and do a test, see what voltage we're getting. So the sun's just come out as well. So we're currently using 183 watts just to run some AC music stuff and other bits and pieces. So let's just have a quick look at what we've got coming in from the roof on the left hand side, which we've just fitted. 198 volts, and from the right side, which is preferential to the sun, 200 volts. So we're well within range of that. I want to see if having them both run in series, which is basically combining both arrays into the same chain, or running them in parallel alongside each other, is going to make any difference. So I don't have a charge controller monitor at the moment. I've only got the smart shunt and the Dali BMS. So it's not telling me exactly what we're getting from the panels, but it'll tell me what's going into the batteries. So let's turn on one circuit and then the other one. This little jumper here is combining these two. So if we look at this, we should see 390 volts, that's spicy. And yeah, we're getting almost 1,000 watts. 1,300 watts, 1,500 watts. So we're at, look, the state of charge is wrong on both of these because I haven't yet got them to a full 100% state of charge and then zero everything out. So while we've got this sun, what I'd like to do is take that jumper out and then run them in parallel, which will effectively double the current and half that voltage. 1,600, call it 1,600 watts. Beefy. And plug this guy back in. Okay, so one bank, which is the right hand side of the bus going down that way. Let's turn this side on as well. So it's dropped the voltage, but massively up the current. 1,000 watts. 600. 700.
Even if